Hi guys, on your physics test, there's some information you just need to memorize, and stuff that you see on this page kind of falls into that category. There's some formulas that you should be aware of, and there are some units that you need to be aware of, and I'm going to take you through each one. If you want to make flashcards, you can. I also have a widget that I made that has a matching game that involves formulas and units, so you can do it any way you want, but you really need to make sure you are very, very familiar with the things that you see here on this page, and I'm going to go through them one by one. Okay, so let's start by looking at each of these different variables. Each one has something to do with motion. You've got distance and time at the top, and neither one of those has a formula associated with them because you just directly measure the distance from one point to another, or you can directly measure how long it takes to go from one point to another, so that's time. But you do need to be aware that there are some units that we use more commonly than others. Traditionally in my class, you're mostly going to be using the meter to measure distance, and you're mostly going to be using seconds to measure time. However, just because those are the most common units of distance and time doesn't mean that you have to use those units. You can use any units you want to for distance and any units you want to for time. However, we tend to stick with the metric system in a science class, but if you weren't in a science class, you might see hours for time, you might see kilometers for distance or hours for time and so on. So you need to be aware of the fact that any distance or any time is okay. Speed is sort of a combination of distance and time, and a lot of you seem to know that, but you're not sure exactly what combination of distance and time. Think of it this way. What is speed? It's how far you go in a certain amount of time. So you're dividing here. So the formula for speed, or average speed I should say, is the distance divided by the time. And whatever units your distance is in, and whatever units your time is in, you're going to wind up with units of distance divided by units of time. And we say like this, let's say we used meters for distance and seconds for time, our units would then be meters per second, which we would abbreviate m/s. The slash is pronounced per. It literally means to divide, because what you did to get your speed was you divided your meters by your seconds. Velocity has the exact same formula. It's also distance divided by time. And again, we're talking about average velocity here over a period of time. So you take your distance, you divide by time, and that's going to give you something that's identical to the speed. So to make it velocity, you have to add one thing, and that's the direction of travel. So you can write that in as north, south, east, west, up, down, left, right, back, or forth. But you have to include a direction in order to technically be considered velocity. And a lot of times in physics, we refer to velocities as either being positive or negative, and that just refers to the direction you're traveling. That a positive direction could be up, it could be to the right, it could be in any direction you want, but the opposite direction is then the negative direction. The units are the same though, except for the direction being added on. So you need to know the formula for speed and the formula for velocity, and you need to recognize the difference between a velocity and a speed. A velocity includes a direction. Acceleration does have a formula, but I did not ask you guys to know it. It's a little too advanced for us. So you don't have to know the formula for acceleration, although acceleration will come up in another formula in a second. But you do have to be aware of the units of acceleration because they come up in some other formulas. So they're kind of weird units. We say that acceleration is meters per second squared. And meters per second squared is written that way because really what acceleration is a change in velocity. So when your velocity is changing, that means every second that you're traveling, your speed is changing, and your speed, the units of speed, are meters per second. So you get meters per second squared because it's a change in a change. So the meters per second becomes meters per second squared. This mostly comes up with the constant that I taught you with the lowercase letter g. That's the acceleration due to gravity. So the acceleration due to gravity is 9.8 meters per second squared. What that means is that an object that is dropped, say from the roof of a building, falls at a rate that picks up speed every second it's falling about 9.8 meters per second faster than the second before. So in the first second of fall, it goes at a rate of about 9.8 meters per second. In the second second of falling, it's going twice that. And in the third second of falling, it's going 3 times that. So you're picking up speed the whole way. The next formula you need to know is force. The formula for force is F equals ma. That's Newton's second law of motion. And the M stands for mass, which is a little confusing because lowercase m also stands for meter. But in this case, it stands for mass. If you want to make yourself a little note of that, that's for mass right there. And the lowercase a stands for acceleration. I'm just going to abbreviate Excel. So your force is equal to the mass of your object times how quickly it's accelerating, and that'll tell you how much force is applied. So when you multiply a mass times an acceleration, mass is typically measured in kilograms, acceleration is meters per second squared, so the units you would get for force would be a kilogram meter per second squared, which is a mouthful and really annoying to say, so they came up with a new unit that means that, and that unit is called the Newton, with a capital N. And then last but not least is energy. Energy actually comes in two forms, kinetic and potential, so there are two formulas associated with energy. But both of them have the unit joules, pretty much just like Newton's. If you look at how the units work out, if you multiply them out in the energy formulas, you get kilograms per meter squared per second squared, which again is a mouthful. So instead of saying all that, we invented the unit called the joule. Both the Newton and the joule are named after famous scientists. And joules has this funny spelling over here, Joules. And here are the formulas for kinetic and potential energy, and we've worked with these quite a bit, so hopefully you're familiar with them. The M in both of them is mass, V in the KE formula is velocity, G is the acceleration due to gravity that I mentioned before, and that is exactly 9.8 meters per second squared. And H stands for the height above the ground. So you might be asked to calculate the kinetic energy or the potential energy on the test. I will probably give you these two formulas though if I need you to do that, only because I know that it can be hard to memorize formulas that are that complicated. But the rest of the formulas that are in here, the three above it, you should definitely memorize. But KE and PE, if you need it, I will give it to you. You do need to know all the units on this page, however. Be really familiar with them, especially acceleration and newtons and joules, because those are the three that everybody gets confused about. So you should definitely be familiar with the acceleration units, the newtons for force, and joules for energy. Okay, that's it for variables and formulas, and I will see you in the next tutorial.